Hello everyone and welcome to this step-by-step tutorial on using Databricks Community Edition to code Python with Apache Spark or PySpark. We already learned that Apache Spark is a powerful and open source distributed computing framework that is designed for big data processing and analytics. It is capable of handling large-scale datasets with speed and efficiency through its in-memory computation capabilities. PySpark serves as Spark's Python API for easy coding. In this lecture, we will explore how to leverage Spark within Databricks. Databricks is a unified analytics platform that simplifies cluster management, and this Databricks provides a collaborative environment for data processing. So we will learn how to setting up a free Databricks account, how to create a Spark cluster, and how to write PySpark code to perform basic data processing tasks. Whether you are a data analyst, aspiring data engineer, or just curious about big data, by the end of this lecture, you will have skills to build pipelines and unlock the potential of big data. So let's get started. First, why Databricks? Databricks is a cloud-based data analytics and AI platform that is designed to unify data engineering, data science, and business analytics workflow. Databricks is built on Apache Spark. It enables scalable processing of large data sets and facilitates collaborative development through its integrated workspace, and it supports languages like Python, SQL, R, and Scala. Databricks empowers organizations to build and deploy data-driven applications efficiently. How? With its features such as Delta Lake for reliable data lakes, MLflow for machine learning lifecycle management, and seamless integration with major cloud providers. Data Community Edition is a cloud-based platform that lets you experiment with Apache Spark without any cost. It's totally free. You don't need to install Spark locally. Just use a browser to access a pre-configured environment. Databricks combines Python simplicity with Spark's ability to process massive datasets. We can write, run, and visualize code in an environment that is similar to Jupyter notebooks. So let's dive in. The first step is to go to this website. So we go to community.cloud.databricks.com. Then in here, we need to sign up. Okay, accept all. Then you add your email here. Then continue with this email. One code will be sent to your email, and you need to just copy paste it. All right, then you can continue with this email. Again, another code will be sent to your email, and just you copy paste it here. So now we are here in the Databricks. So you can see here, welcome Databricks. So this is the Databricks environment. So I'm gonna explain them one by one. The Community Edition has some limitation. For example, it will provide a single cluster with up to 15 GB storage, and automatically it will be terminated after 2 hours of inactivity. But you can always create a new cluster if needed. And don't worry about your code or data. They will remain safely. The first thing that we need to do here is we need to create a compute. So for that one, you just go to the compute here, click on create compute, and in here we can select a name, for example, test1, and Databricks runtime version. You can see many versions are here. So we can choose a runtime version. Normally, it is recommended to use 13.3 LTS or later. This includes Apache Spark and Python. Here we can see a pre-configured environment that include Apache Spark and other dependencies for running data processing and machine learning workloads. The runtime version determines the software stack, like Scala and Spark version, and they are used by the compute resources, or you can say clusters, to execute your code. For example, you can see here 12.2 LTS. LTS stands for long-term support. This uses Scala 2.12 and Spark 3.3.2. Each version specifies Scala and Spark version that they support. For example, this 16 here, they support Scala 2.12 and Spark 3.5.2. Or you can see we have 17 beta here that supports Scala 2.13 or Spark 4. Let's try this 13. And then just you click create compute here. Because we are going to try some basic examples, so this 13.3 LTS that supports Apache Spark version 3.4.1 is fine for us, but you may try the other versions as well. But you should remember that selecting a higher version of Databricks runtime, for example, a newer version like 16, 17, or even 15 compared to 13, may slightly increase the time to create a compute resource. This is due to additional features, libraries, or dependencies that need to be initialized. Finally, I can see this green dot here. That means it's okay, right? This cluster is running, so I can start my coding. So if I click on compute here again, I can see test one is okay, is running. Then runtime is 13.3, and I have 15 GB RAM, and I have 2 active cores, all right? So if I click on here, then I can see the data. Now I'm gonna create a notebook. Databricks notebooks are interactive environment, and in there you can write and run PySpark code. To do that, we go to workspace here, and then we can click on create and notebook here. Then I can select the notebook name, for example, test1, and in here I can start my coding. Then I should select the language here. So as you can see here, Python, SQL, Scala, and R. I'm gonna work with Python here, and then it's ready to work. It's like a Jupyter notebook. So let's write a simple PySpark program to create a data frame, and we perform some tasks like transformation and result display. So we will use a sample data set, and these data sets are provided by Databricks, but also we can upload our own data sets. So to start from PySpark.sql, import Spark session. So this Spark session is your entry point to PySpark, and it connects your code to the Spark cluster, right? So you can press Shift and Enter to run it, and you can see here automatically connect to your most recent compute, that test one. So we should be connected to one compute resource, right? When you see this green tick, it means it is fine. Then here Spark is equal to Spark session dot builder dot app name, right? And here I can select one app name, for example, test, and then here get or create. So again, shift and enter. We can upload our data set to Databricks. For that, you need to go to catalog here, and then you should see this DBFS here, right? If you do not see this DBFS, just click on your username, go to the setting, and in here, go to advanced, and then when you scroll down, you should go to DBFS file browser and make it on, right? So what is DBFS? DBFS stands for Databricks File System, and is the kind of distributed file system layered on top of cloud storage like AWS S3, Azure Data Lake, or Google Cloud Storage. DBFS provides a unified interface for storing and accessing data. By using DBFS, it is easy to manage and process large data sets with Databricks environment. So first, I'm gonna try one sample that they are already available, because Databricks provides sample data set in DBFS. I'm gonna load a sample CSV file. So data frame is equal to spark dot read dot format, and the format is CSV. Then here option, and in here header is true, right? Then I'm gonna load. I need to give an address, right? So in here Databricks dash data sets, then samples, then population dash vs dash price, and data underscore geo dot csv. This is one sample data set available already in DBFS. All right, so then I'm gonna display the first 5 rows of this data set. So show and 5 here. So this is the data set like rank, city, state code, 2014 population statement. So this is a sample data set. This data set, this data underscore geo CSV, this is a data set that contains population and housing price data. This is a sample Databricks data set. All right, so here I want to filter rows where population is more than 100,000, right? So for example, df underscore filtered is equal to df dot function filter. I'm going to use function filter. And what to do here, in here, I need to pass my data frame that I generated here, and there should be based on one attribute. So I'm going to use this attribute, right? So in here, this attribute, and where this attribute is more than, for example, 100,000, then I can show the result in this way, dot show, right? So you can see this is the result where this value is more than 100,000. So you can see here all are more than 100,000, right? Then in our data set, we have 2014 population estimate, we have 2015 median sale price, right? Now, I want to group my data that I have filtered here by state, based on their state, and also I want to calculate the average house price, right? This based on this value, right? So what I do here, I made one new data frame, df grouped, and this one is equal to df filter that I have generated here, df filter, because I want to group by based on this one, right? The filter dot group by, this is a function based on which attribute, based on this state attributes, based on this state attribute. Then in here, I'm gonna use aggregate function, and in here, I need to pass some attribute. Which attribute? This attribute, right? 2015 median sales price, and then here ABG, right? Then this one dot show, right? So you can see this is my data, and state for each state. For example, state Utah 243.3 is the average 2015 median sale price. Also here, I can visualize the result. Databricks Notebook supports built-in visualization. For example, I want to go for display, and in here, I'm gonna pass this one. I want to visualize this one. So you can see what is the difference between dfgroup.show and dfgroup.display. So here we have more options. So you can see here it's better compared to that one. You can click here for visualization, for example. So you can see here that we have generated one bar chart. So you can change the bar chart here, for example, for line. You can have like area, pie chart. Then you can change this one to count, for example. Different kind of parameters you can use. And then also you can change the name of x-axis. You can change the y-axis, a series, etc. And then you can save and see your chart here. So this is our table, and this is the visualization. So we want to create a small data frame from a Python list. So for that one, we need to import from PySpark.sql.types. We're gonna import struct type, then struct field, then string type, and also integer type, right? Then we're gonna define one schema. So schema is equal to struct type, and then in here we're gonna have, for example, struct field like name, and then the type is string type. And false. So this false here, this means nullability. So when we specify false, it means the column is non-nullable. It means it cannot contain null values, right? Then we do the same thing for some other fields, like three fields like name. Then we have age, and this one is integer type. Age is integer type, and it is false. Then another one we have, like, for example, cd, and this is a string type and false, right? That's fine. Next, we're gonna add some sample data. So our data is equal to, based on these fields that we have generated, right? So we need to have, like, for example, employee EMP1, and the age is 35, and he is from, for example, CT1, right? Then we do the same thing for two others, EMP2, EMP3, 33, 34, CD2, and CD3, right? Now we can create a data frame based on these data that we have. So people data frame is equal to spark dot create data frame, and we're gonna pass data and the schema that we have generated. All right. Now we can show this one, right? So people dot show, right? So here we can see name, age, cd, emp1, and also we can do the same thing for display. So here is our data set. So this is how we can generate one data frame, right? So if you click here, you can see your recent notebooks that you work for. You can search different things that you have here. Catalog is for files. So we have DBFS here. These are our data sets that we have. If we generate some output, they will be here. The users are here, and etc. Then we have workflow. So for workflow, you have to upgrade to Databricks subscription. So these workflows is a fully managed orchestration service that enables user to schedule, automate, and monitor complex data pipelines, machine learning tasks, and analytics jobs across multiple compute resources with dependency management and error handling. So for more information, you can study this documentation here. If you want to go for the paid version, so there are three forms: standard, premium, and enterprise. The payment is based on Databricks units. They call it DBUs, and they bill per second for compute usage, plus separate cloud provider costs for virtual machines and storage. Costs are different by cloud provider, region, pricing tier, workload type like data engineering, analytics, and instance type. They have also some discount available for committed user plan like 1 year, 3 years, or spot instance. So for more information, you can go to this address and you can see their pricing. Okay, that's all for today. In this lecture, we learn how to set up a Databricks Community Edition account. We also learn how to create a Spark cluster and how to create a new notebooks. We try to simply, write codes to load PySpark, transform, and visualize data. In the next lecture, we will learn how to practice the big data in PySpark. Please feel free to ask me your questions by leaving a comment below this video lecture.